Welcome. In this video, I'll be talking about some of the basic concepts of sets. This is mostly a video about the vocabulary and notation that we use in discussing sets. So let's start with some of our vocabulary. First of all, what is a set? A set is a collection of objects whose contents can be clearly determined. An element, that's just one of the objects in a set. And well-defined goes to the notion of this last part of our definition of set can be clearly determined. Its contents can be clearly determined. So for instance, if I wanted to create a set of my colleagues, so these would be the math professors at my school, then that's well defined. There'd be no ambiguity about who would be included in that set. On the other hand, if I simply said the good teachers at my school, so good is somewhat subjective, and so it wouldn't be clear to everyone universally who should be included in that set and who should not be included. So when I just say, all the math teachers, it's well defined, but when I say just the good teachers, that is not well defined, so it would not be a set. All right, so let's talk about some of the notation that we'll use in sets. First of all, we often name a set with a capital letter, such as A or B. And the way that we can define that, there are two different methods. One's called the roster method, and another is a set builder method. So in the roster method, if I name the set A, then I can just say, well, A includes the following elements, and I'll use some brackets, and so if I was talking about the set of teachers in my department, I could say, Dr. McBride, and I'll just say Dr. Smith, Dr. Chu, etc. But maybe I'll just say there's three. So that is the roster method, where you just list all the elements, usually in a comma separated list. That's a good method. If you have a small number and it's convenient to write them all out, then I would go with the roster method. But another option is set builder. So I'm going to build or construct the set that I'm going to call B. I'm going to still use braces or brackets. And so the way that this works is we say generically this is X, so all X that meet a certain requirement. So X acts like a variable in algebra. So this is, instead of listing all the different values, we're saying that this could take on different values, but what values can it take on? We'll say X such that, maybe I would say X such that X is a natural number and X is greater than 1. So let's just go through the pieces of this notation when we're using set builder notation. So I can use any letter. In this case, I'm using X, but sometimes it's common that you'll see Y. So this says B is the set of all things that meet this requirement. So X such that. So this bar, again, is read such that X is, and then whatever your requirements are, a natural number, greater than 1. I could have said X such that X is a math instructor at such and such a college. All right. So another set that we'll need to define is the empty set. And so I'm going to just call this C, and we'll say that C is the empty set. So one way to do this is to just not put anything in our brackets. But another common symbol that we'll use for the empty set looks like a 0 with a line through it. Now, I want to make sure that it's clear that this is not the same thing as a set with the number 0 in it. That is not empty. It has an element, and that element is the real number 0. So an empty set does not have any elements in it. Okay, now we said that an element is an object in a set. The next symbols that I want to introduce are these that look like E's. And the second one is like an E with a line through it. So the first one says is an element of, and the second symbol says is not an element of. So I might say that, for instance, 2 is an element of, I'll say set E, where E is the set of all even integers. I could say 2 is not an element of O, where O is the set of all odd integers. So 2 is not an element. So I'll put a little line through it. And then, I've spoke up here of the natural numbers. I want to say that there is a symbol that we can use to represent the set of all natural numbers. Different places you might just see a plain N. In other places you'll see an N with a line through it. So this is the set of natural numbers. And I think that the reason that sometimes you'll see the line through it is because we use capital letters all the time to represent different sets. And so when we want to be very clear that our N represents the natural number, and we're not just using N to represent some other set, I think that's sometimes why you see this line through it. There's not like a slash through it, like I'm using here for not an element of. It's just a line that is parallel to one of the to this side of the that we use to construct the N. So just look at the context, whether it's your textbook or if you're looking at a website, and see if they're using just N to represent the natural numbers, or certainly if you see the line through it, that would always be to represent the natural numbers. And the last bit of notation I want to do is this lowercase n, and then a set of parentheses, and then with the name of a set, a capital letter inside the parentheses. This means the cardinality of set A, and that is the number of elements in set A. All right, and lastly, let's talk about, I want to distinguish between what it means to say that two sets are equivalent and when they are equal. So equivalent means two, or it could be two or more. I'll just say sets have the same number of elements. So if we're talking about sets A and B, I could say n of A, so that's the number of elements in A, equals n of B. In that case, A and B are equivalent. Now, that's different than saying A and B are equal. So A and B have exactly the same elements. So a little bit different there. So let's say that A was defined as 1, 2, and 3. So that's the set that contains the elements 1, 2, and 3. And B has the elements A, B, C. Then, believe it or not, these are said to be equivalent because n of A is 3 and n of B is 3. But they are not equal. So they don't have the same elements, they have the same number of elements. So that's the difference between equivalent and equal when we're talking about sets. So let's look at a couple of um, problems where we'll use these concepts. So this is, all right, I'm going to focus on these questions here in this section, the ones that I've highlighted. So these questions we're going to answer them based on the graph above. So these have different college majors, and then the average yearly earnings. So along this axis we have dollar amounts. These are in thousands of dollars, and then here we're given specifically, what those dollar amounts are. So the first thing that we're asked to do is to use the information given to construct the set of college majors with average yearly earnings that exceed 63,000. So exceed would mean strictly more than, so it's not going to include those that are 63,000. I think there's just the one, and that's the engineers. So we could call this set A, and we're supposed to use the roster method. So that equals the set that just has this one element, which is engineering. And the next one says X such that X is a major with an average yearly earning between 38,000 and 53. Pay close attention. This says is a less than or equal to, and this is strictly less than. So we can include 38,000 on the low end, but we're not going to include 53,000. So that would be these three yearly salary amounts. So I might say B is the set that includes social work and philosophy and nursing. And then I'll close my bracket there. But so no, I'm not going to include journalism, and that's just because this was a strictly less than. Okay, a couple of other examples. This one says use the information given in the previous graph at the bottom of the previous page, and so I'll show that to you in just a moment. And here that is measuring racial prejudice by age. So the bar graph shows the differences among age groups on the implicit association test that measures levels of racial prejudice. Higher scores indicates stronger bias. So here are different age groups. There's below 18, 18 to 24, and so forth. And then these are the average scores on the test. And so these age groups are given group numbers to name them, group 1, 2, 3. And then we have a key here that says if your average is less than 15, then it indicates little or no bias. None of the age groups fall into that. 15 to 35, which I think is most all of the age groups except for this last one, that indicates a slight bias. And then above a 36 is a moderate bias, and so that'd be group 7, the 65 plus. So our first question here, X such that X is a group whose score indicates slight bias. So slight bias, that was groups 1 through 6. So in answering this, I'm just going to say C is the set that includes group 1, group 2, group 3, group 4, group 5, and group 6, okay? And the next one, X such that X is a group whose score is at least 30 and at most 40. So between 30 and 40. Now that's going to exclude group 4 and group 7. So for this I would say this is group 1, group 2, group 3. I'll skip group 4 and go to group 5, and then group 6. So this is giving us a little bit of practice in going from the set builder method to the roster method for constructing sets. So let's go to this last example. So we have a graph here, and it says a study of 900 working women in Texas showed that their feelings changed throughout the day. The following line graph shows 15 different times in a day and the average level of happiness for the women at each time. So based on the information given, represent each of the sets and exercises 113 through 116 using the roster method. So let's look at number 114. X such that X is a time of day when the average level of happiness was 1. So we're looking across, and so this is 1, and there's a time here, here, and here, and so we'll call that, this is going to be set F, and that includes hours 10, 14, and 16. And then for the next question, X such that X is a time of day when the average level of happiness is between 3 and 4. Now, we're not going to include 3, and that's because we have the strictly less than sign. So between 3 and 4. So here's 3, but I can't include that, and here's 4. Now, I need to include 4. So I'm looking at this guy here and here, but not this one. So those were hours 20, 21, and 22. So I'll call this set G, and that includes 20, 21, and 22. All right, so there is there's our some problems where we use our basics of set vocabulary and notation. All right, I'll see you in our next video, and we'll look at some more topics on sets.